Let us see question number 1. Given a series circuits containing resistors of different values, which statement is not true? So the current through each resistor is the same. This is true. And the sum of the voltage drop across each resistor element will be equal to the source voltage. This is true. The total resistance is the sum of the value of all the resistors. That is true. So the voltage drop across each resistor is the same. So this one is not a correct statement because the resistance values is different. The voltage drop across resistance will be different. Okay, so now we see the second questions. How much voltage is dropped across a resistor R3 in the given circuit? So that means we need to know what is this voltage drop here. So now we see to find the voltage drop across resistor R3, we need to find what is the Req for these three resistors. Okay, so we need to find what is the Req for the resistor 2, 3, and 4. So resistors R2, R3, and 4 are connected parallelly. So this is equal to 1 over at D plus 1 over 60 plus 1 over at D. And then we take the inverse of this. Okay, this will give us 24 ohm. So that means we can replace this circuit here. If we're going to replace this, then we have this voltage here, which is 46 volt, and then connected to this R1, and then now this is the resistor that the Req that we have represent the resistor of R2, R3, and R4. So this resistor value is 24 ohm and R1 is 68 ohm. So we want to know the voltage drop across R3. Basically is we want to find this voltage drop here. Okay, this let's say this is the VA over here and this is the ground, right? This is the ground. So we want to find the VA. So this is a series circuits. We can use a voltage divider circuit to find what is the voltage A, right? So the voltage A is equal to 646 volt times 24 plus 68, 68 plus 24. This will give us the voltage across the resistor R3, which is equivalent to 12 volt. So the answer for this is D. Okay. Now we see question number 3. What is the potential difference between voltage A, VA, and VB? Okay. So now in this circuit, we can see that this 4 ohm and 4 ohm are connected in parallel. 5 ohms and 5 ohm from these 5 ohms are connected in parallel. So we can find this Req for this one. Okay. This RA network. So this RA network is equal to 1 over 4 plus 1 over 4. We take the inverse of this. Okay, then we get 2. Okay, so let's assume this is our RB network. So this RB network is equal to 1 over 5 plus 1 over 5 plus 1 over 5. Take the inverse. Then we get 5 over 3. Okay, now we have this. We can redraw the circuit here. Assume that we're going to start with the our voltage source, okay, which is the 50 volt connected to 3 ohm resistor, and then to this 1 ohm resistor, then connect to our RA. Okay, this is where our RA value, which is 2 ohm, and then connected to our RB value, right, is 5 over 3 ohm. And then so this is routed to the negative terminal of the battery. Okay, so we want to know what is the V and VB. So in this case, we can see here, this is the A we need to know, and this is the B we need to know. right? So to find the potential difference between A and B, basically is we need to know what is the VA and VB. So in this case, VA, we can use the voltage dividers formula to find this. So the VA is equal to 50, okay, times the Rn Rb, which is the 2 plus 5 over 3, then divide by this total equivalent circuit, which is 3 plus 1 plus 2 plus 5 plus this 2 plus 5 over 3. This will give us the VA value, which is equivalent to 23.91 watt. Then we find the VV. Okay, so VV is equal to 50. Okay, and the numerator is 5 over 3 divided by 3 plus 1 plus 2 plus 5 over 3. Then we get the VV, which is 10.87 volt. So the potential difference between the VA and VV, VAV, which is equal to VA minus VV, right? So we have the 23 minus 1 minus 10.87. Okay, so there's roughly we get about 13.04 volt. So the answer for this is D. We see question number 4. When a semiconductor is forward biased, which of the following statement is true about the direction of current flow? For a diode, the current flow will always flow from the anode to cathode. So the answers for this is B. Okay, so next we see what is the power dissipated by R2, which is R2. This is our R2, this is R4 and R6. Okay, so what is the power dissipated on this? Well, we need to calculate the power is equal to V square divided by R. So means we need to find what is the voltage here. Then we can calculate what is the power dissipated across resistor R2. So in this case, what we can see here, we can put some node here. Let's say this is node A, this is the node B. So in this node B here, we can calculate this. Okay, the network of the equivalent resistance RB, network of this RB, this is equivalent to 1 plus 6, which is parallel with 7K resistor. So this gives us 3.5, right? And then this will be parallel again with this R2. So the RA network is equivalent to 3.5, okay, plus 2K, and then this is parallel with 8K, right? So down for this, we get 3.26. Okay, so now we can redraw this circuit here. We have this R1 and then connected to our RA network circuit here equal to 3.26K and R1 is 3K, right? So now we need to find what is this VA here. Then we can find the VA here using the voltage divider circuit. What is the VA? So VA is equivalent to the voltage source, okay, times the RA resistor 3.26K divided by 3K plus 3.26K. So here you get the VA 57.8 volt. So after you get a VA, then you're going to put this into equation V squared divided by R2 to find the voltage across the resistor. So here we have 57.8. We take the square divided by the R2 at K. So roughly you will get 417.6 milliwatt. So that means the closest answer for this is this question's A, which is equal to 1417. Okay, so this is the closest answers. So answer is A for this.